Hello students, today we are going to discuss the subject called water supply engineering, in that the unit named environment and ecology. The contents in this video we are going to discuss are the water requirements for domestic purpose, industrial purpose, firefighting, public purpose, and the different losses during supply. So we'll discuss in detail the following the purposes. First, we'll go through the water requirement, the demand, the supply, the requirement, the importance of water, the necessity of water. We are going to study this. First, the reason behind the requirement of water is for different conditions like drinking, washing, cleaning, and so on. All the above conditions are necessary to all kind of animals, plants, and other things on the earth. And water uses are differentiated with respect to the utilization considerations and depending upon the places water being used, supplied, and demanded. The different purposes are categorized based on the water requirements for the uses. They are domestic, industrial, firefighting, public, and the different losses during water supply or water being used. So in this image you can see how the water is required. First, the components of industrial water requirements, the process, domestic, firefighting, and the losses. In the sense, whatever the process it's been taking for water supply, water treatment, and other things. Similarly, when it is being treated, it is being sent to the domestic purposes. Similarly, it is being used when it is necessary, like firefighting. And during supply, there might be some type of loose connections between the pipes, or there might be low watertight connections. Due to that, there might the water being losses. So these are the different components. Similarly, when it is coming to the projected demand, we have two types in that: the theoretical demand and the additional demand to be safe. So theoretical demand we will be discussing in this chapter in detail in the further units, in the further videos. Theoretical demand in the sense, what will be the demand for the domestic purposes, industrial purposes, firefighting, public uses, so on. How it will be used, we will be discussing or dealing it in theoretical way by using some formulas, or by understanding, or by getting some knowledge from the public. Then additional demand to be safe, in the sense we will be taking the water in consideration, and in the future consideration too. We will be considering both the ways, the water consumption as well as the future consumption. On the behalf of these two, we will be saving the water for future. Similarly, the last total demand after considering factor of safety, it is total water requirement. Or after all considering, after we are going to consider all these parameters, components of industrial water requirement and projected demand, we come to an conclusion that the total demand after considering factor of safety will be our daily demand, or monthly demand, or it might be yearly demand for a given area, or the boundary, or the city. Next, so wherever we use the water, it's been displayed in this: domestic, industrial, institution, agriculture, so on. It's the list, it is being continued. I'm just going to concentrate on these points. Next, we'll go with the different purposes the water it's been used. First is domestic purposes. In this, the water required in the houses for drinking, bathing, cooking, washing, so on. The list is again, it is a big one. Just concentrate on these important things. It is the main thing, the purposes it's been used in households. Next, mainly depend upon the habits, social status, climatic conditions, and costumes of people. As per IS 1172/1963, under normal conditions, the domestic consumption of water in India is about 135 liter per day per capita. So whatever the numbers I have said, like IS 1172/1963, it is the code. It's been developed in the year 1963. This is the year where it's been published, and this is the code on which the normal conditions of water, or it might be the domestic consumption of water in India, they are being uh, thoroughly explained in this code. And in this code only they have mentioned that about 135 liter per day per capita. Capita per day, per capita, in the sense a person is going to have 135 liters of water in a day. Next, this is the process how the water is being used. First, we will be collecting the water and we will be sending through pump, and we will be storing, we will be using it for heaters, and again we will be using it for washing machines, and again wash basins, taking baths, and if you have any type of extra wash basins where you will be using it for washing some type of vessels, there you will be supplying the water. So this is how the water is being used. One is water heater, washing machine, wash basins. This is the bath, shower, and the tap, and there will be some other connections of water utilities. Next, we will go to the industrial purposes. Wherever you find industries, there you require more water. You please remember this. First, the water required is in the industries mainly depends upon the type of industries which are situated in the city. The water required by the factories, paper mills, cloth mill, cotton mills, breweries, sugar refineries comes under industrial use. The quantity of water demand for industrial purpose is around 20 to 25% of the total demand of the city. In the previous slide, I have been explained the domestic purpose, where a person is going to have 135 liters of the water in a day. Similar way, for a city, how much the water is being supplied? Among that, 20 to 25% of water it's being demanded only for industrial purpose. So please note it off. Next, this is the overall view of a industry where the water is being supplied to that, and again the wastewater it's been thrown out in the river, the water itself. Next, we'll go to understand how this firefighting purpose is helping in the society. First, during the fire breakdown, large quantity of water is required for the throwing it on fire to extinguish it. Therefore, provision is made in the water work to supply sufficient quantity of water or keep as reserve in the water mains for this purpose. The quantity of water required for firefighting is generally calculated by using different empirical formulae, in that for Indian conditions, Kuchlings, it is he is the scientist. Behalf of his name, they have been established a formula saying that Kuchling's formula gives a satisfactory result with the formula Q is equals to 3182 square root of P, where Q is the quantity of water required in liter per minute. For 1 minute, how much the liter is required. Then P is the population of a town or a city in thousands. P in this formula we will be taking in the value of thousands. In the sense, if it is 10,000s, then in the P value you will be entering it as 10. If it is 1 lakh, it will be 100. 10 lakhs, it will be 1000. So it's gone. Next. So this is the simplest way to understand. There is a fire, it's been catched in a house, and a firefighter is been supplying, or he is been watering the house to extinguish the fire. Next, there is a public use. How this water is being used in public. The quantity of water required for public utility purposes such as washing and sprinkling on roads, cleaning sewers, watering of public parks, gardens, public fountains comes under public demand. The public means wherever you find the public. It might be on the roads, or it might be on the footpaths, or it might be near your gardens, the parks, wherever you see the public is being roaming, there we say it as the public properties. So wherever you see this type of public, there you will be supplying the water to gardening, for different types of fountains. You might be having some type of roads, you need to clean it, you will be using the water for cleaning it. To meet the water demand for public use, provision of 5% to 5% of the total consumption is made designing the water works for the city. So a day, whatever the city is going to accept the water, among that the 5% of water it's been used for public use. So here a man, you might be knowing him, he is the Mr. Bean. He is watering the land. It is the garden in front of his own house, and he is being put some seeds on the ground, and he is pouring the water. Similar way here on the left side, he is the water tank. It's been cleaning the road, and you can see a rainbow because the sunlight it's been passing through that water. And on the right side you can see a fountain. It is the public garden where the fountain is being used. Next, we'll understand why these losses and the wastes are happening. First, losses due to defective pipe joints, cracked and broken pipes, faulty valves and fittings. As I have said, the losses it is because the loose in connections between the pipes, or it might be defective in piping joints. There might be chance of cracks due to the heavy movements of the vehicles on those structures where the joints are being provided. Similarly, you might find some broken pipes during transporting. You might think that it is a minor one. Later it will be problem when the water is being supplied. And when it comes to the faulty valve and fittings, you might be knowing. Next, the losses due to continuous wastage of water. Whenever you garden the water your gardens, there you will be leaving the water continuously. It is not necessary that you need to leave that water continuously. You just spray on the grass or the tree, it will absorb the water and it will store the water in the soil, and whenever it is required it will be taking it from the soil. losses due to unauthorized and illegal connections. These are happening in India much more in numbers. Still, it is a little bit less nowadays because the government has been said that there will be 24 hours continuous water supply to the houses. So this unauthorized and illegal connections are less nowadays. While estimating the total quantity of water of a town, allowance of 15% of total quantity of water is made to compensate the losses, thefts and wastage of water. So whatever the demand, whatever we have calculated, using that Kuchling's formula, Q is equals to 3182 square root of P. Using that, whatever the quantity we have been found, Q is equals to around 300 million liters. It's been supplied to the city of Belgaum. So now we need to consider the losses and the wastes. You might not be knowing that where is the cracks, where is the loose joints. You might be not knowing it. So considering 15% of the total, whatever the quantity we have been found, 300 million liters, we are going to exceed with 15% of that. In the sense, we will be sending 345 million liters to the city of Belgavi, all over the Belgavi, and the extra loss or the theft or a wastage, whatever it is going to happen. Apart from that, the water it's been supplied to the respective houses continuously. In the sense, extra 45 it's been lost or wasted. If it is not wasted, then some of the families will get more water rather than the other houses which are far from that treatment plant or the supplying plants. So this is the one example where the pipe it's been broken and the water it's been spraying in just like the fountain. And there is one more where the work is been happening using the JCB, and they unknowingly he broke that pipe. Later that person, the PWD officer, he is going to come on, he is going to check the damage, and he will be helping in solving this problem. So this ends with the video. Thank you. If any queries, please let me know.